And the Fermi Paradox. Where is everybody? Welcome to infinite scientific exploration, where curiosity knows no bounds. Today we're diving headfirst into one of the most profound mysteries in the cosmos, the Fermi Paradox. Named after the brilliant physicist Enrico Fermi, this paradox highlights the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for it. Think about it. Our galaxy alone, the Milky Way, harbors hundreds of billions of stars, many of which are orbited by planets. So, with so many cosmic cradles for life, where are all the alien civilizations? That's the crux of the Fermi Paradox. Today, we'll explore 5 of the most compelling explanations for why we haven't yet shaken hands, or tentacles, or whatever appendages they might have, with our cosmic neighbors. The rare Earth hypothesis. Is Earth uniquely special? So you look up at the night sky and you see countless stars, each potentially hosting planets. It's a mesmerizing sight, isn't it? The vastness of space, filled with twinkling stars, each one a potential sun to its own solar system. You might think, with all those worlds, there must be life out there, right? Surely in this immense universe, Earth can't be the only cradle of life. Well, the rare Earth hypothesis throws a bit of cosmic cold water on that idea. It suggests that the conditions necessary for life, especially complex life, are not just rare, but extraordinarily rare. This theory suggests that the conditions that gave rise to life on Earth, and complex life in particular, are incredibly rare, maybe even unique in the universe. Think about it. Our planet has a perfect blend of factors that make life possible. It's like winning the cosmic lottery, not just once, but multiple times. Imagine the odds of everything aligning so perfectly. Think about it. Earth sits in what we call the Goldilocks zone around our sun. Not too hot, not too cold, just right for liquid water, which is essential for life as we know it. But that's not all. This zone is just one piece of the puzzle. We've got a relatively large moon that stabilizes our planet's axial tilt, preventing wild climate swings. This stability has been crucial for maintaining a climate that can support life over billions of years. And let's not forget our protective magnetic field, shielding us from harmful solar radiation. Without it, life as we know it would be impossible. The rare Earth hypothesis argues that this combination of factors, a stable star, a life-supporting distance, a large moon, a magnetic field, might be extremely uncommon on other planets. Each of these elements plays a vital role in making Earth habitable. It's like finding a planet that's not only the right size and temperature, but also has a friendly moon and a built-in force field. The odds of all these factors coming together are astronomically low. In essence, this theory suggests that we might be much more alone than we'd like to think. The universe, vast and full of potential, might still be a lonely place for complex life forms. It's a humbling thought, reminding us of how precious and potentially fragile life on Earth truly is. Our planet, with its diverse ecosystems and life forms, is a rare gem in the vast expanse of space. We must cherish and protect it. The Great Filter, a cosmic roadblock for life. Now let's delve into a more sobering possibility, the Great Filter. This concept is both fascinating and terrifying, as it suggests that the universe might be filled with countless dead civilizations that never made it past a certain point. This theory suggests that somewhere on the path from simple life to advanced civilizations, there's a wall. A barrier that is so formidable, it stops most life forms from progressing further. A hurdle so high, so impossibly difficult to overcome, that it prevents most, if not all, civilizations from reaching interstellar travel, or perhaps even surviving long enough to try. This could explain why we haven't encountered any other advanced civilizations despite the vastness of the universe. This filter could be anything. It might be a natural phenomenon or a self-inflicted catastrophe. It could be the incredibly improbable leap from non-living matter to self-replicating life. This initial step is so complex and rare that it might be the first major hurdle. Or maybe it's the evolution of complex, multicellular life from single-celled organisms, a transition that took billions of years on Earth. This step required a series of fortunate events and conditions that might be exceedingly rare in the universe. But the Great Filter doesn't have to be in our past. It could be a challenge that lies ahead of us, waiting to test our resilience and ingenuity. It could lie ahead of us, a looming threat that wipes out civilizations once they reach a certain level of technological advancement. This could be a point where our technological prowess becomes our downfall. Think nuclear annihilation, runaway climate change, or some unforeseen technological disaster. These are all potential great filters that could spell the end for our civilization. The chilling implication of the Great Filter is that if it exists, then we, as a species, have either already cleared it, making us incredibly lucky, or we're inevitably headed towards it. This realization forces us to consider our place in the universe and the precariousness of our existence. It's a sobering thought that forces us to confront the potential fragility of our existence and the challenges that might lie ahead on our cosmic journey. As we continue to explore and push the boundaries of our knowledge, we must remain vigilant and mindful of the potential obstacles that could stand in our way. Chapter 3. Lost in Space. The vast distances between us. Imagine standing on the edge of an ocean, shouting a message into the wind. The vastness of the sea makes it highly unlikely that anyone would hear you, even if they were standing on another shore. The universe, my friends, is like that ocean, but on a scale that's almost impossible to comprehend. Even if other intelligent civilizations are out there, the sheer distances between stars and galaxies could be so immense that communication or even detection becomes nearly impossible. Think about it. The fastest thing we know of, light itself, takes years, centuries, even millennia to travel between stars. A message sent from a civilization 1,000 light-years away would take, well, 1,000 years to reach us. And that's assuming they're using technology similar to ours, which might be as primitive as smoke signals compared to what they've developed. This theory highlights the limitations we face as a species bound by the laws of physics and the vastness of space. It's a reminder that even if we're not alone, the universe can still feel awfully lonely. Chapter 4. The Zoo Hypothesis. Are we being watched? Have you ever been to a zoo and watched the animals? You observe them, learn about them, but you don't interfere with their lives. Now imagine that on a cosmic scale. That's the essence of the zoo hypothesis. This theory proposes that advanced extraterrestrial civilizations are aware of our existence, but choose to observe us from a distance without making direct contact. It's as if Earth is a cosmic nature reserve, and we're the unwitting inhabitants. Why would they do this? Well, maybe they're studying us, much like we study animals in their natural habitats. Or perhaps they're waiting for us to reach a certain level of technological or social development before deeming us worthy of contact. The zoo hypothesis raises some pretty profound questions. Are we being monitored by unseen cosmic caretakers? Are they waiting for us to pass some intergalactic test before welcoming us into the galactic community? Or are we simply a curiosity to them, a fascinating example of life evolving on a backwater planet? It's a thought-provoking idea that challenges our assumptions about our place in the universe and the possibility of encountering other intelligent life. Chapter 5. The Firstborn Hypothesis. Are we the pioneers? What if we're the first? What if, in the vast expanse of the universe, humanity is the initial spark of intelligent life? What if, in the grand symphony of the cosmos, humanity's tune is the first of its kind? Imagine the universe as a grand orchestra, and we are the first notes played. That's the intriguing proposition of the Firstborn Hypothesis. This theory challenges us to rethink our place in the cosmos. This theory suggests that we might be among the first, if not the very first, intelligent civilizations to emerge in the universe. It posits that we are at the forefront of a cosmic journey. It's a bold claim, but consider this. The universe, as vast and ancient as it is still relatively young. In cosmic terms, it's still in its infancy. Stars and galaxies are still forming, and countless worlds are yet to be born. The universe is a dynamic, ever-evolving entity. It's entirely possible that the conditions for intelligent life, while rare, take billions of years to align just right. The right mix of elements, the perfect distance from a star, and the right amount of time. If we are indeed among the firstborn of the cosmos, it places a tremendous responsibility on our shoulders. We are the trailblazers, the pioneers of a new frontier. We become the pioneers, the trailblazers for any future civilizations that might arise. Our actions today could set the stage for the future of intelligent life. The legacy we leave behind, the knowledge we accumulate, could shape the destiny of intelligent life in the universe. Our discoveries, our achievements, and even our mistakes will be the foundation for those who come after us. It's a humbling yet exhilarating thought to think that we might be standing at the dawn of intelligent life in the cosmos, with the potential to shape its future in ways we can only begin to imagine. We are the first chapter in a story that could span the entire universe. So there you have it. 5 of the most compelling explanations for why we haven't yet encountered our cosmic neighbors. From the unique conditions of Earth to the vast distances between stars, the Fermi Paradox continues to challenge our understanding of the universe and our place in it. While we haven't found definitive answers yet, the search for extraterrestrial life goes on. Scientists are constantly pushing the boundaries of technology, scanning the cosmos for even the faintest whispers of distant civilizations. The universe is full of mysteries, and the Fermi Paradox is a testament to our insatiable curiosity and our desire to unravel the secrets of the cosmos. And who knows, maybe one day the silence will be broken and we'll finally have an answer to that age-old question: are we alone?